Okay, today's lesson is lesson 6, and it's all about vectors. So vectors, remember, are quantities that have a magnitude and a direction. So they need to have a number, and they also need to have a direction associated with them. So magnitude just means amount or number, and then direction could be up or down, north, south, left, right, it depends. But we always put the direction in square brackets, okay? So a vector, if we were to draw a vector, it's an arrow. So here's our vector. This is the tail, or the start of the vector. And then the arrow represents the tip or the end, okay? So in this case, this vector is pointing to the right and up. So positive, positive, okay? So vectors have a couple other parts to them. Vectors have an x component. So the x component is the component that goes in the horizontal direction. And then vectors also have a vertical component. And the y component, which is vertical. Okay? So x component, y component. Okay, so really what this is doing is it's forming a right triangle where you have an x, you have a y, and then you have a hypotenuse. So this is the hypotenuse. So maybe you can already see it. We're probably going to spend a little bit of time today doing some trigonometry, okay? There's an angle that's represented there. So when we describe a vector, we can do it in a few different ways. Like we could give this side and an angle. So we could say, let's go with, this could be 25 newtons. And then for an angle, I should have thought of this before. Let's say it was 30 degrees north of east. Okay, that's one way we could describe a vector. So the actual length of the vector is 25, and the angle would be 30 degrees. Okay, that's one way we could describe the vector. We could also describe the vector in terms of its x and y components, where we would say whatever the x component is, whatever the y component is. So there's a few different ways we can describe vectors, and it's going to be important for us to know how to do both or do all of these different versions. Okay, so very quickly, vector quantities include acceleration. We also have displacement. We talked about velocity, and of course, this whole unit is about force. Those are all vector quantities, okay? So we're going to look at how to draw some examples of vectors. We're going to start with a vector that's 12.5 meters west. So west, typically, is to the left. So if we were drawing 12.5 meters to the left, it would go this way. And we're going to have our arrow point to the left, representing that the direction is west. Okay, so this would be 12.5 meters. Now, if we thought about what our x and y components were for this vector, well, our x component along the horizontal is 12.5. Now, it's 12.5 to the left, and typically, left is a negative direction. So the x value is negative 12.5. The y value for this vector, well, it doesn't have one. It doesn't go up at all. So it's just a 0. Okay? So the reason it's negative, because it points left. And left is a negative direction. Okay? Let's look at a vector for 50 newtons north. North is typically in the up and down direction. Okay? So because it's north, our arrow is going to point up. This arrow is pointing in the north direction. Okay? So 50 newtons. If we thought about this in terms of x and y, well, the x component for this vector, well, it doesn't go to the right or to the left, so it doesn't have an x component. Our x component is 0. For a y component, well, it's going 50, and up is a positive direction. So we just write 50. Okay? If we want it to be perfectly correct, we should put our units outside the bracket like that. Okay? So instead of writing 50 newtons north, we could represent it as this. Okay? Now let's look at a couple of trickier examples. We're going to have a vector that is 25 newtons, 45 degrees to the north of east. So northeast, that's going to be up and to the right. So 45-degree angle from the horizontal. I have a protractor, but why actually measure out the angle? Okay, so this is 25 newtons. Now, 45 degrees means that it's going to be forming an angle of 45 with the horizontal, right? So this angle here is 45 degrees. Now, if we want to think of an x component and a y component, well, this is going to be a little bit trickier. We don't know what the x and the y is, but we do have one side of our triangle, and we do have an angle, which means we could use some trigonometry to figure it out. So some of you might look at this and say, well, can't we use Pythagorean theorem? Well, we don't have enough information. We don't have two sides. If we have two sides, we can figure out the third side, but we don't. We just have one side, but we do have an angle. So I'm going to use two different colors to represent the sides. Let's call y the green color, and let's call x the blue color. So x is really the adjacent side, and y is really the opposite side. So that means that our actual value is the hypotenuse. So let's start with x. X is adjacent. We know the hypotenuse and we know the angle. So if we have adjacent and hypotenuse, we're going to be using cosine. Okay? So for x, cosine is equal to adjacent over hypotenuse. Okay? That means cosine theta is really equal to the 25 newtons, the unknown side, over the hypotenuse, which is 25 newtons. Okay? You know what? I'm going to leave this as hypotenuse for now. We're going to rearrange the equation so that we have x by itself. So to get x by itself, we're going to multiply both sides by hypotenuse. That means that on this side, hypotenuse cancels out, and we're left with x is equal to hypotenuse times cos of theta. All right, well, let's put our numbers in now. Hypotenuse is 25 newtons, right? Cosine of 45 degrees. So we can punch into our calculator 25 times cos 45. Now, note your calculator does need to be in degrees, not radians. And we get a side of 17.7. Okay, so really what this means is the x component is 17.7 newtons. Okay, let's do the same thing for y. So y is our opposite side. If we have opposite and hypotenuse, we would be using sine. Okay, now you might be thinking, well, why can't we use this side? We just found it. Well, we had to round this number, so it's best to always use information you're given when you're finding stuff. So we're going to use what we were given, which was 25 and 45, and we're looking for opposite. So we're going to use sine. Sine theta equals opposite over hypotenuse. Okay, which really, the opposite side is our y that we're trying to find. So let's do the same thing and get y by itself. So we're going to multiply both sides by hypotenuse. Hypotenuse cancels out, and we're left with y equals hypotenuse times sine of theta. Hypotenuse was 25, sine of 45. Well, when we have a 45-degree angle, that means the other two sides are the same. So let's see if we get the same answer. 25 times sine 45. Oops. 17.7. So really, y is also 17.7 newtons. Okay, so what we've done, x and y were hard to find in this case, okay? We had to do trig to find our x and our y. Now we found that our x is 17.7 and our y is 17.7. Now they both go right and they go up. So both of those are positive. So our x and y are positive 17.7 and positive 17.7 newtons. Okay? So both are positive because up and right are positive. All right, let's look at another example. 4 meters per second, 20 degrees south of west. Okay, southwest. Southwest will be down and to the left. Okay, so our arrow is going to go somewhere down here. I'm going to put it like this. Okay. Now, we usually measure from the horizontal. That's just kind of like a thing we do. So we're going to draw the horizontal first. Instead of drawing the horizontal down here, we want to draw the horizontal right from the end, or the start, sorry, of that vector. So there's our x component, and there is our y component. Now this is 20 degrees, and it's south of the west. So west is like our reference angle, and then we're 20 degrees to the south of that. Okay, so I'm going to still use blue for x, green for y. This is still our adjacent side, and then y is still our opposite. Okay, we like to set it up so that x is always adjacent and y is always opposite. Okay, just kind of how we do. So we're going to try to find the x and y. And again, we have to do some trig. So the good news is we know the angle, we know the length. It's 4. So if we're looking for x, we can use the standard formula that it's going to be hypotenuse times cos of theta. Okay, hypotenuse times cos theta. Hypotenuse is 4. Cosine of 20 degrees. That means our x will be 4 times cos 20, which is 3.8. Okay, let's do the same for y. Now instead of having to always do the work every time, y is always going to be hypotenuse times the sine of theta. So hypotenuse times sine of theta, 4 meters per second times sine of 20 degrees. Our y is 1.4. Okay, so let's report our components. So the x and the y. Well, our x we found to be 3.8. Now, it's going to the left, which means it's going to be a negative 3.8. Our y we found to be 1.4, but it's going down. So that means it's negative 1.4. So the components of this vector, by seeing the negatives, you know that this vector is going to the left and it's going down. Just like these ones were both positive, which meant the vector was going to the right, and up. Okay? All right, I know that was a lot just for one page. So what do we have next? Okay, let's look at an example. We have Curtis skating 12 meters to the north and then 5 meters to the east. Okay. Well, we like to put our horizontal direction first. Okay? So if he's going 12 north and then he's going 5 east, those are the two different vectors. Okay? But let's start with our horizontal one, just to make our lives easier. He's going 5 meters to the east, and he's going 12 to the north. We want to find his net displacement. What the heck does that mean? That means his overall displacement. So if he went 5 and then he went 12, he traveled a total distance of 17, but his actual displacement would be represented by this distance. So this is how far he is from where he started. If he started here and he ended here, this direct line represents the displacement. So how are we going to find the third side of our triangle? Let's use Pythagorean theorem. This is our unknown, it's our hypotenuse. That's our c squared. Okay, how do we find c squared? Well, a squared plus b squared. Okay, it doesn't matter which side we call a and which side we call b. Let's call a is 5 and b is 12. 5 squared plus 12 squared. Well, I don't need my calculator. 25 plus 144. 25 and 144 gives us 169. Okay, so c squared is equal to 169. Now, that's c squared. We need to find c by itself, so we're going to have to take the square root. Square root of 169 gives us 13. So c equals 13 meters. Okay? So that means that this side is 13 meters long, but we also need to find one more piece. We need to find the angle that he traveled at. So, how the heck are we going to find the angle? Well, we have our opposite side and we have our adjacent side. Opposite, adjacent. If we have opposite and adjacent, we're going to use tangent. Tan of an angle is equal to opposite over adjacent. Well, tan theta, the opposite side is 12, the adjacent side is 5. So tan theta equals 12 divided by 5, which is 2.4. Now that's not our angle, that's the tan of our angle. We need to take the inverse tan of 2.4, and when we do that, second function tangent, we get 67 degrees. So what this means is Curtis's overall displacement is 13 meters, and then we also have to include our angle. How we do that is we put our reference direction first. So whatever direction is first, or whatever direction we measured that angle from, that's our first direction. So we measured this angle from the east. So we put east, 67 degrees, and then we were north of east. Okay? You could also say 67 degrees north of east, because this is like our reference direction and we measured from that direction. Okay, this part ends up being a little bit tricky, but we practice it a lot. Okay? Okay, let's look at a few more examples. Braden is training for track and field. He jogs 435 meters north and 100 meters west. So he's going to the north, and he's also going to the west. Okay, we're going to put our horizontal one first. So he goes to the west, 100 meters, and then he is doing 435 meters north. So that's going to be up. Okay, so what is his displacement? Well, his displacement is going to be found just like we kind of did. So we're going to go and connect the end to the start. Okay, so this is his displacement. I guess we could call it C again. And we know the two sides of our triangle. So we can find the third side. We can also find the angle. So C squared equals A squared and B squared. So in this case, C squared equals 100 squared plus 435 squared. We're going to get a really big number. 100 squared is 11,000. 435 squared is that. So overall, our C squared equals 200,225. But we got to square root both sides, square root. We're left with C is equal to 447 meters. Okay? 447 meters. That's the easy part. Now we got to find the angle. To what angle did he end up moving? Well, let's do it the same way. Tangent is opposite over adjacent. So we're going to have the opposite side as 435. We're going to have the adjacent side as 100. 435 divided by 100. I don't know why I use my calculator for that. 4.35. Now that's not our angle, remember. We need to take the inverse tangent of that. Inverse tan or second tan is going to be 77 degrees. Okay, so that means that Braden's displacement is 447 meters. For direction, our reference angle is to the west this time. So west, 77 degrees, and then we went to the north. Okay? Finding components. Okay, we've done this before. Remember, we have an x component and we have a y component. I'm going to redraw this because they showed our vertical direction first, and we don't usually like that. This is going to be our x, and this is going to be our y. Okay, we need to find our x, we need to find our y. Now, if this is a 60-degree angle, that means that this angle is 30 degrees. So we're going to ignore all of that. We're going to use this as our x, this is our y. All right, finding x. Remember, hypotenuse times cosine of the angle. This is on your formula sheet, okay? Hypotenuse in this case is 50. Cosine, our new angle, is 30 degrees. 50 times cosine 30 gives us 43.3. That's our x. For y, again, this is on your formula sheet. It's our hypotenuse times sine of the angle. Our hypotenuse is 50. Sine of 30 degrees 50 times sine of 30 is 25. Okay, if we were not to change our triangle, our y would have ended up being adjacent and our x would have ended up being opposite. And we don't like this. We always like to have where x's are adjacent and y is our opposite. Okay, that's why I redrew this, because then these would be flipped and they'd be wrong. Okay, so our x and y components, well, x is going to be a positive because it's to the right, so 43.3, and our y is down, which means it's negative, so those are our components. Right, positive, down is negative. Okay, let's do it again. Okay, this is drawn right. We have our horizontal and we have our vertical. X, y. X is our hypotenuse times cos of theta. Our hypotenuse in this case is 60 times cosine of 40 degrees. 60 times cos 40 gives us, well, 46.0. For our y, it is hypotenuse times sine of theta. So that will be 60 newtons times sine of 40 degrees. 60 times sine of 40 is 38.6. I realize that you can't see my numbers on my calculator like at all. So those are our components, 46 and 38. Now, let's write them in proper components. Our x is to the right, so that means it's positive. Our y is up, which is also positive. Okay, and then newtons. Okay, easy peasy. Okay, Mr. Kobe's pushing the laptop cart down the hall with a force of 115 newtons to the west. So that will look like that. Thomas tries to be funny and steer her off course, so he applies a force of 65 newtons south. So 65 newtons south would be a down. Okay, what is the resultant force on the cart? Can you figure out the angle? So we're going to need to find our triangle side again. Okay, let's put our horizontal one first. 115 newtons. Thomas tries to be funny. Pushes with 65 newtons south. Okay. That means that we are trying to find the other side of our triangle. So we're trying to find this number and that angle. Okay? That's what we're saying when we're saying resultant. We're like looking for the answer, or the third side of the triangle. So let's use good old Pythagorean theorem. Let's call A 115, B is 65, so 115 squared plus 65 squared. Oops. 115 times 115 is 13,225, plus 65 squared, which is 4,225. Add those two together, we get c squared equals 17,450. But that's c squared, we would just want c. Square root both sides. Square root of that bad boy is 132 newtons. So that's how hard we're pushing together. So I'm pushing to the west, Thomas is pushing down. So altogether we are pushing harder, but I'm also being pushed off course. So we want to find what angle I got pushed off course. So we're going to be using tangent again because we know the adjacent and we know the opposite side. So opposite over adjacent, that means tan of theta is equal to 65 over 115. So 65 divided by 115 gives us 0.565 blah blah blah. That's not our angle, that's tan of the angle. So we need to take the inverse tan. Second function tangent of our answer is 29 degrees. Okay, so what is the resultant force? The total force is 132 newtons, and the angle is, okay, our reference angle is west. Then our angle is 29, and we got pushed to the south. Okay? All right, let's kind of look at drawing vectors. So we've actually been drawing vectors the whole time, but we're going to actually walk ourselves through it. So let's say you want to add two vectors together. One of those vectors is going to be this guy here. Okay? In terms of an x and a y component, we're 3 to the right, and we are 1 up. Okay? Let's say we want to add that to this vector here. In terms of x's and y's, we're 2 to the right, and we are 1, 2, 3, 4. 4 down, so we are -4. If we want to add those two together, what we have to do is we have to attach them. So we want to put the tail of this arrow right against this one. So I'm going to redraw this. Stick with me. I'm going to attach that guy there, and I'm going to attach this other vector right so that they're together. So the arrow of one meets up with the back of the other. Okay, this plus this. What we get is we're going to connect the dots. So overall, this red arrow plus this red arrow gives us this blue arrow. Now if we think of our blue arrow as an XY, 1, 2, 3, 4, 5 to the right, so that's 5 in the X, and we're actually 1, 2, 3 down, -3. So what we can do if we were to add these together, let's add our x's together. 3 and 2 gives us 5. 1 plus -4 gives us -3. Well, would you look at that? If we just add our x's together, we get a new x. If we add our y's together, we get a new y. And it's the exact same as if we were to draw it. So if we know our x and y components for vectors, we can actually add our vectors together. Okay? Let's look at one more example so that you know I just didn't magically make that happen by accident. Let's look at a vector where it is, let's look at this guy. So it's 2 to the left, so -2, and 3 down, -2, -3. Let's add it with this vector. So for an x, we're 1, 2, 3, 4 to the right, so +4, and we're 1 up, so 1. Let's add those together. So we're going to have to connect our tips and our tails. This is our first one. Now we're going to have to attach the end of this one to the arrow here. Okay, so we get something like this. Our answer, we're going to put our tails together, our tips together. We end up with one that is 2 to the right, and 2 down, so negative 2. Well, let's see if we just added our components together, if we would get the right answer. Okay, negative 2 plus 4 is 2. Negative 3 plus 1 is negative 2. Well, would you look at that? It gives us the exact same answer. So basically, if we want to add vectors, we need to know x and y for all of them. Okay? Now you might be thinking, well, we've already kind of added vectors together. Technically here we were adding them, but the thing is they were easy. X component here is negative 115. Y component is 0. X component is 0. Y component is 65 down, or negative 65. If we were to add these together, we would get negative 115, negative 65. Basically telling you that the sides of your triangle are 65 and 115, which is exactly what we had. Okay? These are just really simple examples where we don't think of them as components because one of our components is a 0. That makes our life easy. So let's look at a case where we have different directions here. We've got a student pushing a table across the room. One student is applying a force of, she's applying a force of 16 west. And the table is resisting with 3 to the east. So that means it's resisting with this much, okay? We're going to add these together. In order to add them together, we need to have x and y. Our x here is negative 16. Our y is 0 because there's no up or down. Here, our y is 3. Our x is 3 to the right, so plus 3. Our y is 0. If we add those together, negative 16, 0, and 3, 0, we get an answer of negative 16 plus 3 is negative 13, 0. So our resulting vector would be a little bit shorter than this, and it's 13 newtons. Okay? When you have components that are 0, you don't really have to do it formally this way. We could think of this as a number line, right? 16, if we want to find the overall, we sum the forces. We have a force to the left. Our net force would be negative 16 plus a 3. Negative 16 plus 3 is negative 13. We've already done this, but we were finding our net force when we were just going in opposite directions. Okay, we sum all our forces together. Any force to the left is a negative. Any force to the right is a positive. We end up with overall 13, negative 13, or 13 to the left, or 13 west. Okay? So we've already been doing this. It's just our vectors were going along the same plane. They were just along the same dimension. But that's not going to happen all the time now. Okay? This is like the big one. This is probably the hardest type of example you would see. Okay? We're almost done, I promise. So we have two students who are pushing a cart down the hall. One student is pushing it with 25 newtons, 15 degrees north of east. Okay, 15 degrees north of east, we're pushing it like this direction. Okay, we're going to have an x component to that force. and we're going to have a y component, okay? The other student is pushing it with 31 newtons south of east. While south of east, we're going to be going down this time. Okay, so we're going to also have an x component and a y component. X and y. We want to find what these two things together equal. Now, in order to add these together, we need to have components first. We can't just add 25 and 31. We need to add them based on their x's and on their y's. So the first step is going to be to find x and y for each. Okay? How the heck are we going to do that? Well, we know that we have a magnitude, so 25 newtons, and we have 15 degrees. For this triangle, we have 31 newtons, and we have 19 degrees. So we can find x and y, we can find x and y, and once we have x and y for both, we are going to add components. So we're going to add our x's and our y's. All right, we'll leave it at that for now. Okay, so if we're trying to find the x for this, x is equal to hypotenuse times cos of theta. Our hypotenuse is 25, cos of 15, okay? X will give us an answer. For our y component, it's going to be hypotenuse times sine of theta, or 25 times sine of 15, okay? So let's punch that into our calculator. 25 times cos of 15 gives us 24.1. Actually, let's go to 2 decimals, 24.15, okay? For y, 25 times sine of 15 gives us 6.47, okay? Our x is right, so that's positive. Our y is up, that is also positive. Those are the components for this vector. Let's do the same for this vector. X is going to be hypotenuse times cosine of our angle, which is going to be 31 times cos 19. Y is going to be hypotenuse times sine of theta, which is 31 times sine of 19. Okay, let's punch this into our calculator. 31 times cos 19 gives us 29.31. 31 times sine of 19 gives us 10.09. Our x component is to the right, so it is positive. Our y component is down, so it is negative. This was step 1. We found our components. Okay. Step 2, we need to add our components together to get our net force. Because remember, finding F net means you add all forces. We have 2 forces, 1 force, 2 force, but because we had an angle, we had to find our x and y before we can add them. So now, step 2, 24.15, comma, 6.47 plus 29.31, comma, negative 10.09, we're going to get an overall force. So 24.15 plus 29.31 gives us an x of positive 53.46. 6.47 plus a negative is really just take away 10.09. So we get a y component of negative 3.62. Okay? So these are the components for overall force. Okay? And what these components are telling us is that there's another arrow or another side of a triangle that we have to find. Okay? So if we have a triangle that's going positive to the x and negative for the y, we're going to be going to the right and we are going to be going down. Okay? So to the right and down. So 53 to the right is quite large, and we are only going down by 3, so that's a pretty small arrow. Okay? So our overall force is described by these components, but what we're going to do is we're going to actually find the magnitude or the amount. This is the overall force. This is our x, which is 53.46. This is our y, which is 3.62. We need to find this side of our triangle. Okay? How are we going to do that? Pythagorean theorem. Okay? This angle we are also going to need to find. So step 3 is find the magnitude of the net force, which is the hypotenuse, using the x and y that you found. Okay? So this is step 3. C squared equals a squared plus b squared. A squared, 53.46 squared, 3.62 squared. And we punch that into our calculator. 53.46 squared plus 3.62 squared gives us 2,871.076. Now we are trying to find c, not c squared. Square root both sides. C is 54 newtons. Okay? Now we found our side, we need to find the angle. Tan theta is opposite over adjacent. Our opposite side is 3.62. Our adjacent is 53.46. 3.62 divided by 53.46, 0.067, blah, blah, blah. That's not our angle. That's the tangent of the angle. So we have to second function tan it, and we do get a small angle. Okay, the reason we get a small angle is because one side of our triangle is really big and the other side is really small. So it's a very, very, very small angle from the horizontal. Okay? So the net force is 54 newtons. Now our angle, we measured from the east, and it was 4 degrees to the south. Okay? All right, this was a really big lesson. I'm going to give you a few days to work on it. I might actually even break up the daily task into smaller sections. Okay, but basically to summarize, you need to be able to find vector components. So you need to be able to find the x component and the y component for a vector. These are the formulas. Then if you're going to add vectors together, you need your x and y first. You add your x's and your y's together to get your new components for your overall force. Once you have those components, you find the magnitude of your hypotenuse, and you use tangent usually to find your angle. Okay? All right, thanks for watching.